All right, in this video, we're going to talk about number bases in positional systems. So we actually kind of prepared for this in our last section when we talked about the Babylonian system and the Mayan system. So we have a base 10 system, but there's other bases that are used like base 2 and base 8. Like I know with computers, those are two common bases that are used. But anyway, let's go ahead and practice going back and forth between the numbers that we write, Hindu-Arabic numbers, which are base 10, and other bases. So let's go ahead and review real quick. It says here, for the Hindu-Arabic base 10 numeration system, name the numerals. All right, so you should be thinking 0 through 9, the digits 0 through 9. We call those numerals. Okay, and then name the positional values or the place values. Well, we have the ones place, the tens place, or 10 to the first power, 10 squareds place, or the hundreds place, the 10 cubes place, the 10 to the fourth place, and so on. So notice here it says any counting number greater than 1 may be used as a base for a positional value numeration system. Now, they use the word positional value here. I'll use that, but you'll also see me use place value. It's used pretty much the same way. All right, let's look at number 2. It says, using number 1 above as a guide, determine the numerals and positional values for a base 8 positional value system. So I would encourage you to look at the example or look at what we already did and see if you can figure out the numerals and positional values in a base 8 positional value system. All right, so for numerals, now keep in mind, in a base 10 system, notice there's no digit for 10. It's all the digits up to 10, so that would be 9, 0 through 9. Notice there's 10 digits, it's base 10, but we don't actually have a single digit that represents 10. So that's something to remember. And then notice base 10 is powers of 10. If it's base 8, we're going to be looking at powers of 8. All right, so our numerals are 0, 1, 2, 3, 4, and 5. And you're going to go all the way up, not to 8, but to 7. So notice we have 8 digits, 8 numerals, and if it's base 8, we won't have a digit for 8 in that system. And our positional values will be 1, and then 8 to the first power, then 8 squared, 8 cubed, oops, it should be to the fourth. Let me fix that one. And so on. So think about this. We really have the 8's place, the 16's place, the 24's place, and so on. And then note at the bottom here, 240 with the subscript of 8 is read 240 base 8. In fact, some people will just use an 8 as a subscript there. All right, so let's move on to the next slide. So converting from other bases to Hindu-Arabic or base 10. All right, so it turns out we're going to go both directions. This is probably the easier of the two directions for most students. So let's go ahead and I'll show you the steps that I want you to use. So you'll see in all these conversion problems, the first thing we're going to do is write out our numerals. Well, since it's a base 5, we're going to go from 0 to 4. And then if you take your positional values, we always start at 1. And then since it's base 5, it'll be 5 to the first power, 5 squared, 5 cubed, 5 to the fourth, and so on. Now, here's the thing. You only have 2 digits here. And so you're only going to need 2 place values. And so let's go ahead and now that we know the two positional values, 1 and 5, we can convert this number. So 23 base 5 is going to be equal to 2 times 5 ones, or I should say 2 5s, or 5 to the first powers, plus 3 times 1, or 3 ones. So the 2 is in the 5's place, and the 3 is in the 1's place. And so when we simplify this, we're going to get 10 plus 3, which is 13. Now, if you think you understand how to do it, you might want to try the next one and then watch the video. All right, so let's go ahead and do this. Our numerals, well, it's going to go from 0 not to 8, but 7. And since it's base 8, we're going to look, our positional values will start at 1, and then it'll be 8 to the first, 8 to the second, to the third, to the fourth, and so on. Now, since our number 270 base 8 has 3 digits, we're only going to use these 3 place values. So the 1's place, the 8's place, and the 64's place, basically. So 270 base 8 is going to be equal to our first digit, 2, which is in the 64's place, or I'll just say 2 times 8 squared, plus, now the 7 is in the next positional value, which is the 8's place, so that's 7 times 8, plus, and we have 0 ones, 0 times 1. And so 2 times 64, that's 128. 7 times 8, we'll get 56. 0 times 1 is 0. And when you add 128 and 56, you get 184. So 270 base 8 is equal to 184 in our system. All right, let's move on to the other direction. Oh no, actually, I'm sorry. We have 2 more examples to do. So again, each time I would encourage you to try them on your own and then watch the video. Let's go ahead and see how you did here. All right, so first of all, our numerals are going to go from 0 to 5 if we have 302 base 6. So we'll go from 0 to 5 in a base 6 system. That's the numerals that we use and the only ones. And then our place values, again, it'll go the 1's place. And then since it's base 6, it'll be 6 to the first power, the 6 squared's place, the 6 cubed's place, and so on. Now, we have 3 digits, so we're only going to use 3 place values. So we'll have the 1's place, the 6th place, and the 36's place. And so 302 base 6 is going to be equal to 3 times 6 squared, or 3 times 36, in parentheses, plus we have a 0 in the 6's place, so 0 times 6 in parentheses, plus we have 2 ones, 2 times 1, and so we're going to get 3 times 36 plus 0 plus 2, and so that's going to be 108 plus 0 plus 2, which is 110. Now, number 6 is a little challenging. If you're up for a challenge, definitely try that one and then watch the video. All right, so let's see. Our numerals are going to be 0 and 1. So for a base 2 system, again, 2 will not be a numeral, just 0 and 1. We have 2 digits, and our positional or place values, let's see, we'll start at 1. This is going to be long because we have a lot of digits here. So we have 2 to the first power, 2 squared, the 2 cubes place, 2 to the 4th, 2 to the 5th, 2 to the 6th. Let's see, notice there's 6 digits here, so we need 6 place values. That takes us from 1 to 2 to the 5th power, and all the other powers of 2 in between. So 101101 base 2 is going to equal, so let's see, the 1 is in the 2 to the 5th place positional value. So it'll be 1 times 2 to the 5th. And then we have a 0 in the next place. It'll be 0 times 2 to the 4th power, plus, since we have a 1 next, that'll be 1 times 2 to the 3rd power, so that's our 8th place. And then the next one we have is a 1, and it's in the 2 squareds place, so 1 times 2 squareds comes next. And then we have 0 in the 2's place, so 0 times 2. And then finally, we have a 1 in the 1's place, so it'll be 1 times 1, so plus 1 times 1. All right, so 1 times 2 to the 5th, that's 32. 0 times anything is 0. And then 1 times 2 cubed is 8. 1 times 2 squared, that's 4. 0 times 2 is 0, and 1 times 1 is 1. When we add 32, 0, 8, 4, 0, and 1, we're going to get 45. All right, so I'm going to stop this video, and then I'll do the next one going in the opposite direction.